Okay, now let's take a look at this section. This is the second page, I believe, of my notes, the bottom half. A limit of sine of x over x as the x value approaches to 0. We agree that this was one of my previous videos. You could also look at this from page 60. Bottom half of page 60 will cover this topic. So limit of sine of x over x as x approaches 0 will be 1. But we're going to, more importantly, we're going to use that idea to get the limit of this particular expression. So what is the limit of tangent of x over x? Which is essentially tangent of x times 1 over x. But tangent of x, you could rewrite that as sine of x over cosine of x. So tangent ratio is simply the ratio of sine to cosine, y over x. So your problem changes to this. You could modify your problem to finding the limit of sine of x over cosine of x times 1 over x, and just manipulating that expression a little more. Let me find some space to write that. So so in multiplication, the order doesn't matter. So sine of x times 1 over cosine of x times x, I could switch the order of the product right here, x times cosine of x, as opposed to cosine of x times x. So I could write that as the sine of x over x times 1 over the cosine of x. So I'm manipulating this expression to become this expression right here, okay? And now I'm finding the limit of a product, so I could use the product rule. So you have the limit of sine of x over x times the limit of 1 over cosine of x as the x value approaches 0. X value approaches 0. And then we know that this answer, right, is right here. That value is equal to 1. And then 1 gets multiplied by this value. Unfortunately, cosine of 0 is defined. Okay, we know what cosine of 0 is. Cosine of 0 is 1. 1 divided by 1 happens to be 1 as well. So 1 times 1 in the end gives you the answer of 1. This is, by the way, if you want to look into this, this is example 5 on page 63. Now let's take a look at, okay, so now let me erase what I have here. Let's take a look at the next example using graph. I informally talked about this earlier, okay, when I was introducing the idea of the limit. You have something called the right-hand limit and the left-hand limits. I won't write anything on here for now. If you take a look at the graph, take a look at the x value of 1. Your right-hand limit is the limit of that function from the right side. Okay, from the right side, what is the, as you get closer and closer to 1, what's the y value becoming? The y value is becoming 1 from the right side. So we say that the right-hand limit as x approaches 1 is also 1. The left-hand limit from the left side, it happens to be 1 as well. Okay, so your left-hand limit is 1 and your right-hand limit is 1. Okay, even though your f of 1 is defined to be 2, but that's not the limit. Okay, the limit has to do with the trend. It has to do with the pattern. It has to do with the behavior of the function or the graph. Okay, so how do we write a proper notation for this? Okay, so for the right-hand limits, we say that the limit of, we'll say this is f of x, limit of the function f of x as the x value approaches 1 from the right side. The plus sign right there appears, the plus sign that um, implies that we're trying to find the limit of the function f as x approaches 1 from the right side. And then from the right side, your y value will become 1 right there. Okay, on the other hand, the left-hand limits, so limit of the function f as the x value approaches 1 from the left side is equal to 1. And when your right-hand limit agrees with the left-hand limit, that becomes the limit of the entire function at that particular point. So because of these two facts, we could conclude that the overall limit of f of x as x approaches 1 is equal to 1 because they agree, they match. Okay. Now notice at 2, your left-hand limit doesn't match the right-hand limit. Okay, your limit from the left side will be 2 for the function. The limit from the right side, however, will be 3. Okay, so the actual limit for the function at 2 does not exist, okay, because they don't agree, they don't match. Okay, does the limit exist at 4 even though it's not defined at 4? If you look at the left-hand limit, and the right-hand limit, they do agree, so that the limit of the function as x approaches 4 is equal to 2. Your left-hand limit is also 2, your right-hand limit is also 2.